Hello, so at this moment I will be discussing about the laboratory activity number 4, which is the stability analysis of control systems using the Routh Hurwitz. So, okay, let's start with the code. Okay, so as you can see here, first is that I've imported the library needed, which is the import simpy as sp, and assigned the variables s, k, just this sp symbols for s and k, and the coefficients we have the 1, 4, 5, and the k. So now we are going to define the root table coefficients. Use this one, which is to build the root array. So we have for the n is equal to the coefficients, and the m is equal to n plus 1 over 2, and for the root is equal to sp, that's zeros and comma. Okay, this one here, the row 1 coefficients, this line here, so this means that we are going to create the row 1 is the coefficients of the even numbers, or from 0 or the 0 and the 2, okay, and then added just if needed the zeros, and then here this one is to complete the columns. So if ever to complete the required columns, this one here states that. Same with the row 2. Okay, next for the root, this one here just states how the numbers will be put on together in the array. Okay, and here this is to fill out the empty rows in that array, okay, or in that matrix. This is using the Routh Hurwitz formula. Okay, next is that the rt is equal to root table coefficients. So this will finally display what happened in this whole code. Okay, and then finally my name here. Okay, let's see how it goes. Okay, as you can see here in the terminal, this is the output of the code. So this is the output. As you can see here, we have the matrix of the 1, 5, or the table. This is actually the table, the Routh Hurwitz. Hi, this is the table, the complete table. We have 1 and 5, 4, and the k, and then here this is what is missing but not filled out using the formula, then 0 and k, 0. So this actually matches for the computations I've made manually. Okay, as you can see here. Okay, so this is what I've made manually. I've constructed the root table also, and they are the same. Okay, you can see here for the coefficients of s cubed and s squared. Okay, this matches. So that is the root table for this lab. Okay, so that's all, and thank you so much.